Hi Geometry. Let's look at Unit 4 Lesson 10 and how to find the area of a polygon. Remember, a regular polygon means that all the sides are congruent to each other in the same length. So this pentagon, since it has 5 sides, this pentagon has 5 congruent sides and also has 5 congruent interior angles. All the interior angles are congruent. So let me erase that now because I'm going to be writing on this. So to find the area of a regular polygon, the area formula is area equals 1/2 the perimeter, that's the distance around our polygon, times the apothem. So the apothem, we're going to abbreviate with a lowercase a. So area equals 1/2 the perimeter times the apothem. So what is this apothem? The apothem, if this is the center of my pentagon, the apothem is a line segment that goes from the center to the midpoint of one of the sides and intersects at a 90-degree angle. So this apothem, if you will, is going from the center perpendicular to one of my sides. So that's an apothem. And when you and I get ready to do a problem, our apothem is going to be the altitude of a triangle. So let's take a look at one of these problems. It says, what's the area of a regular pentagon? That means it has 5 sides, and I can count them, with side length 6 meters. So let's think about breaking this pentagon down into 5 triangles. I'm going to connect the vertices to the center and create these, create these 5 triangles. In one of these 5 triangles, let me get a different color. I'm going to drop down an altitude. Remember, the altitude of a triangle goes from a vertex perpendicular to the other side. This red altitude of this triangle is my apothem for the entire pentagon. I split it up into these 5 triangles so that I could get this red apothem that I'm going to put A by. So when I think about my formula for area, and I'm on purposely writing it way over here, I remember it was 1/2 the perimeter times the apothem. So I need to go calculate some things. First of all, the perimeter is pretty easy. Let's talk about perimeter. There are 5 sides, and they're all 6 centimeters in length. So the perimeter, I would add up all 5 sides that are 6, and I get 30. So the perimeter of this problem, 5 sides that are all 6, is 30 centimeters. So that's part of it. But now I also need this apothem. Well, how am I going to find this? We're actually going to use our trig skills. So in this problem, this apothem with this side to the, with this line from the center to the vertice creates a right triangle. There's a red right triangle inside of this pentagon. So I'm going to find out the degrees of this angle right here. So there's 360 degrees all the way around the center of this pentagon, and I have split it into 5 triangles because there's the 5 vertices. So 360 degrees divided by 5 is 72 degrees. So each one of these larger triangles have a 72-degree angle, and all 5 of those add back up to 360 degrees. But my little red triangle I drew is not the entire 72-degree angle. It's half of that. I split one of these blue triangles in half to get my red one. So 72 divided by 2 is 36 degrees. This is a 36-degree angle. And I know if the entire side is 6, then this half a side right here is 3. So I'm going to do trig on this little red triangle. If I'm using the 36-degree angle, let me grab a green pen. This is my opposite side. My apothem is my adjacent side, and this side that I don't know anything about is my hypotenuse across from the right angle. So using my SOHCAHTOA, let me write it up here at the top. Using my SOHCAHTOA, I have opposite and adjacent, so I'm going to use tangent of this 36 degrees equals opposite 3 over my adjacent apothem. So my variable's in the denominator. Let's multiply both sides by it to get it up and out of the denominator. Then I'm going to have to divide by my trig function, and I get my apothem is equal to 3 divided by tangent 36. And so I'm going to put that into my calculator, and I get approximately 4.13. So I know my apothem now, and I know my perimeter. Let's go find my area. My area equals 1/2 my perimeter, which is 30, times my apothem, which is 4.13. So I throw those all into my calculator, and I get 61.95 centimeters squared. That comes from the fact that my apothem, since I'm measuring in centimeters, my apothem is in centimeters, my perimeter is in centimeters, so when I multiply them, of course, I get my label of centimeters squared for area. Let's go drop down to the third problem on this page because it's exactly like this one. So let's do them both at the same time. So let me move past this regular hexagon to this octagon. And I'm going to mimic all the same work. I'd like to find the area. My area, I know, is 1/2 the apothem times the perimeter. So let's go find the perimeter of this, because that's pretty easy to get. My side length is 4, and if it's an octagon, that means there's 8 sides. And so I'm going to do my 4 times 8, and I get a perimeter, a distance around of 32 centimeters. So now I need to go find that apothem. So to do this, I need my little triangle inside my octagon. So let's start by drawing the center of my octagon, and let's connect all the vertices, all 8 vertices. It's hard to draw straight with my Apple pencil, sorry about that. And when I do that, I get 8 triangles, 8 red triangles. And 360 degrees divided by those 8 triangles gives me 45 degrees. So each one of these red triangles is 45 degrees. And when I add up all 8 of those 45-degree angles, I'm back to my 360 degrees all the way around the center. So I'm going to drop down an apothem in any of these red triangles. I'm going to drop down this apothem. It's perpendicular to the opposite side. And if the entire side is 4, I know this side right here is 2. And I'm trying to figure out my apothem. So I really need this angle so that I could use trig on my blue triangle. And if you're like, well, why don't you do trig with the 45-degree angle? Because my red triangles aren't right triangles. But my blue triangle, when I drop down that perpendicular apothem, my blue triangle is a right triangle. So let's take that 45 degrees and divide by 2. When I do that, I get 22.5. So this angle, this blue angle, is 22.5. So this is my side. Let me grab my green pen. The 2 is opposite the 22.5 degree angle. The apothem is adjacent to it, and this side that I don't know is my hypotenuse. So this is another problem where using my SOHCAHTOA, I'm going to use tangent. So let's write the tangent equation for this triangle. Tangent of this 22.5 is equal to opposite 2 over apothem A, which is my adjacent. So I'm going to multiply my A up and out of the denominator. I'm going to multiply to the other side, divide by my tangent, and I get my apothem is 2 divided by tangent of 22.5. When I plug that into my calculator, I get approximately 4.83. So now I'm ready to calculate my area. My area equals 1/2 my apothem, 4.83, times my perimeter of 32. And when I calculate that, I believe I get 77.28 centimeters squared. Again, because I didn't write it. But technically that apothem is measured in centimeters as well. My perimeter is in centimeters, and so my area is squared. So what happens when they give me the apothem? Well, my math is a little bit different because I don't need to go find my apothem, but I do need to go find my side length. So in this problem, I don't know the distance of my side, but I do know my apothem. So I can't find my perimeter right now. So this is a regular hexagon, meaning there are 6 sides. So if I connect the center of my hexagon with each of the 6 vertices, I create these 6 red triangles. And inside these 6 red triangles, I have my blue right triangle made out of that apothem. And so now I need to go figure out what this blue angle is in my right triangle. So the entire center is 360 degrees around it, and I just split it up into 6 red triangles. 360 divided by 6 is 60 degrees. So each of my red triangles has a 60-degree angle in it. When I add up all 6, I'm back to my 360. But my blue triangle is half of that 60. So my blue triangle has a 30-degree angle. So I know that this half is 30 degrees. So now to calculate this apothem, to calculate this perimeter, where's my eraser there? To calculate this perimeter, I need a side length. So I need to find this side length. I'm going to call it X. And remember, it's just half the side. It's from my right angle to my edge. So it's only half the measurement I need. But in this problem, this is my opposite side. My 10 is my adjacent side to my 30, and my unknown side is my hypotenuse. So this is going to be another tangent equation. So tangent of, and this is helping me calculate my side length. That's what I need. So tangent of this 30 equals opposite x over adjacent 10. Multiply both sides by 10. I get 10 times tangent 30 equals x. When I do that math, I get 5.77 equals x. Now be really careful. Number one numero uno mistake I see kids make is they go use the 5.77 to directly calculate perimeter by multiplying it by 6, since there's 6 sides. But remember, you just found half a side. So technically this entire side, an entire side is going to be 2 times 5.77. And so a side length is actually 2 times this 5.77. The entire side length is 11.54. So the entire side length is 11.54. So now we're ready to go find my perimeter. Perimeter is my number of sides, which is 6, times the length of each side, which is 11.54. And when I multiply those, I get 69.24. So you and I are now ready for my area formula. Area equals 1/2 my perimeter, which is 69.24, times my apothem, which is 10. When I multiply those, I get 346.2 centimeters squared, because my perimeter is in centimeters and my apothem is it's really 10 centimeters, even though it didn't say that. So that was a little bit different. Let's go do another problem that is exactly like that. Let's go to the next side of this worksheet. So let's look at the top of this worksheet. This is a pentagon. I know that because there is 5 sides, and I'm given an apothem, and I know that because it's drawn from the center perpendicular to the midpoint of a side of my pentagon. So this problem is giving me on my apothem. I don't need to find that, but this is the type of problem where I need to figure a way to find my side length. After I find my side length, I need to figure out then my perimeter. And once I know my perimeter, I've got all the information I need to use that area formula, which was, remember, is 1/2 the perimeter times the apothem. So let's split this pentagon up into triangles. There's going to be 5 triangles this time when I connect the center to all 5 of my vertices. So I take my 360 around my center and I divide it by 5 and I get 72 degrees. But remember, this little angle in my right triangle is not the 72 degrees. It's half of that, if you remember that from the other page. So this is really going to be 72 divided by 2, or 36 degrees. This is a 36-degree angle. And this is my opposite side. This like little half is the opposite side of my triangle, and it's X. And so let me get a green marker. This is my opposite side. The apothem is my adjacent side, and I don't know my hypotenuse. So I'm going to set up a tangent equation. And when I set up my tangent equation to find this x, tangent of 36 equals opposite over hypothem. I'm going to multiply my 5 over and get 5 times tangent 36 equals 3.63. But remember, that's only half of it. If I want to calculate my entire side, I need to take my that 3.63 and I need to multiply it by 2 to get the other half of this side over here. So the entire side length is 7.26. Again, number one mistakes kids make, and it's a bummer because you're doing all your math right. You just forget to double to get your entire side length. So my perimeter is all 5 sides times that 7.26. And when I multiply 5 times 7.26, I get 36.3. So when I find my apothem, I get 1/2 times 36.3 times my apothem of 5. So my area for this problem is 90.75. And there's no units here at all, so I'm just going to say units squared on this problem because it's an area problem. So when you get ready to do this worksheet, if you're not in the classroom, because I'll let kids in the classroom realize this, there are 2 problems that don't have to be done this way. First of all, number 1 is, we know that these are regular polygons. So number 1 is an equilateral triangle. So you could do this one with the old school triangle formula, which area equals 1/2 base times height, and my height would be this missing measurement. Your base is the entire 12, and so you would need to figure out your height. You could use your 30, 60, 90 rules if you wanted to, like we did in the classroom just a little more than a week and a half ago or 2 weeks ago. I'm not sure at this point. But you need to find your h, and you could use that formula. Or if you look on the answer key, I did an apothem problem. I found my apothem and then multiplied times my perimeter, which was 36, and I got my area. Same thing with the square. Honestly, if they're going to give me the side length of a square, I mean the area of a square is just side squared. I don't think I would do all this work to find that area. I think I'd just plug it into side squared. So another option, and I would certainly do that one here. If I was making an answer key for number 1, I'd also just find h and then use the grade school formula for area of a triangle. But like I said, on the answer key, number 1 is done with an apothem, and number 5 is done by doing side squareds. If you have any questions on any of these homework problems, please bring them to class. Thank you.